So at the top of the page, it says that f of x, that notation means, as we've mentioned before, that's nothing new. Okay, f is a function of x. So think back to your machine, your function machine back in 8th grade. You have your x's coming in. Are the x's the inputs or outputs? Inputs. Okay, so if we think about it as the machine, the output f of x is determined by the input x. So output is f of x, input is x. We can write a rule, so anytime you graph, so an equation, that matching exercise we did, those were all equations, right? Those are all rules. Okay, an equation is a rule. We can look at the graph, we can look at a table, we can look at a set of points. Today we're going to write the function rule or equation based on the table rules. So we're going to talk about the independent versus the dependent variable. So I want you to draw your x and y axes off to the side. On the back side, we're going to look at situations or functions that we'd actually use in real life. And when we're graphing, the real life problems or those applications are in quadrant 1. Okay? So the independent variable represents your domain. Okay, so your domain is the x. We know that. So domain is x. So there's the independent variable. I'm just going to abbreviate. And then your range, or your y values, are the dependent variable. I've gone back to this a couple of times. You remember the question where somebody started with some cookies in the cookie jar and then they took out 2 per day? Remember that classwork? So in that question, to determine the number of cookies in the jar, you had to know what day you were on, correct? So the number of cookies depended on the number of days. So the number of days was your x. So we've already taken a look at some of these. The number of cookies was your y. Okay? We just said more or less that star, and then a function rule is an equation that describes the relationship between your domain and range. So I want you to take a look at the tables in number 1. There's 3, A, B, and C. And then the tables in number 2, A, B, and C. So if you're watching the video, pause it. In class, I'm going to pause the video and you're going to take time to, or pause the recording, and you're going to look at the graphs. What's similar between, in number 1, the tables for A, B, and C? Okay, so they all are similar in some way. And then A, B, and C in number 2 are different than those in number 1. So what are the similarities and what are the differences? So if we start by taking a look at number 1, I want you to make note that in each of these tables, A, B, and C, the x values as you move from one to the next increase by 1. Okay? And then the y values, now I say y because in table A, they use x and f of x. Okay, this is really your x and your y when you look on the calculator. Because your y is your dependent variable or your range. B, I don't like when someone asks a question on this, it has y and g of y. Okay, they could also call this p and g of p. Or C of P. It's all just a notation with the x and f of x or g and g of y. On your calculator, this would be your x and this would be your y. So it's just noting that this is the input and this is the output. Okay? So back to the changes. So the change of x was by 1. What's the change of y here? In B?
2.
And C?
2.
When you compare your change of y to change of x, that is your rate of change or slope. And because it was constant, it stayed the same from one point to the next. That change, that means these are all linear functions. So when you write them, it should be in the form y equals mx plus b. So who can tell me In number 1 now, how do I go from an x value of 1 to an x value of 5? That same change will happen with a 2 to a 6, and a 3 to a 7, and a 4 to an 8. Yeah, Jack?
You're adding 4 to it?
We add 4. Good. We add 4 to get the y value. So x plus 4 gives you the f of x. That's the rule. If you went to your calculator, I'll just do it for this one, and you typed in y equals x plus 4, and you went to your table, if I go to an x value of 1, sorry, my table's starting at a really small value. Here's the 1, 5. Here's the 2, 6. And here's the 3, 7, and 4, 8. So you can always check your answers by using your calculator. So what's going on in still number 1, but B? How are we going from the x to the y? Nietzsche?
Wouldn't it be one? Wouldn't it be y x?
Yep, we are adding itself. And another way of adding, so instead of saying 1 plus 1 equals 2, it's 1 times 2 equals 2, 2 times 2 equals 2, or 4, 3 times 2, let's undo that, I got ahead of myself. 3 times 2 is 6, and 4 times 2 is 8. So we take that y value, multiply by 2 to get the g of y value. We typically don't write it with the g of y on the other side of the equal sign. You always see it on the left. It really doesn't matter. But we always get rid of the dot 2 and just write 2y. And the last one. This one can be a little tricky. So I want you to pause the video if you're watching it. See if you can figure out C before we go over it. Okay, yeah. So people are stuck on this one. We had one person get it. Okay, so if you couldn't get it, can you at least recognize that it's linear? So your slope is change of y over change of x, which what's the change in the y each time? 2, and then the x? So we have a slope of 2. So if our m is 2, we can pick a point to find the b. What point do you want to use? 3, 7, 4, 9, 5, 11? 3, 7. So we'll use these, and from a previous unit, we're going to do y equals mx plus b, plug in a y value of 7, an m of 2, and an x of 3. And the b's look like 6's. So 2 times 3 is 6. 7 minus the 6 is 1. So our rule is going to be, I'll write it up here, h of x equals a slope of 2, so 2x plus 1. So it's y equals 2x plus 1, plugging in the b in the slope. Yeah, nice job. So now, the bottom ones, let me see if you can recognize, they're not linear. And when I give you a function to write that's not linear, it's going to be as easy as A, B, and C in number 2. Elijah, question, or you have A? We knew that A, B, and C in number 1 were a constant rate of change, and they were linear. Down here, these are all increasing by 1, but are the y values increasing by the same? No, this is increasing by 3, this is increasing by 5, this is increasing by 7. So if there's not that constant rate of change, that means these are non-linear. So it could be absolute value, it could be square root function, could be square function, could be cube root function, could be any of those nonlinear. So in this one, what do we do in the x's to get the y's or f of x's? Yeah? Multiply by itself, so 1 times 1, yep. 2 times 2, 4. What's another word out of those functions that we know? It's the square. It's the quadratic. So 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16. So f of x is equal to the x squared. What about the next one? Kevin? You cube it. So 1 cubed is 1, 2 cubed, 8, 3 cubed, so on and so forth. So we take the y, we cube it to get g of y. And the last one. What's going on in C? The numbers got smaller, so that should give you a hint, Sarah. Square root. The square root of 1 is 1, square root of 4, 2, square root of 9, 3, square root of 16, 4. So we take the square root of x to get the h of x. All right, here come the word problems or applications. So real life situation. Now, not real life for any of you. Well, I shouldn't say that. Do you guys pay your cell phone bill? No. Okay, some of you do, some of you don't. Right now, probably with the cell phone plans, you probably have a limited text and limited calls, right? What you have to pay for is your data. Okay? And if you're at school, if you're at a library, you can always, at the mall, you can log into the Wi-Fi and not use your data. So in this question here, it says the cost to subscribe to an internet service provider consists of a flat fee of $15 per month. And then you're going to be charged $2 for every gigabyte of data. So to find out your total bill or your total cost, you have to think about your flat fee plus the $2 per gigabyte. So I want you to right now to identify which is the dependent variable and which is the independent. Remember, dependent is your y or x. Is it your domain or range? It's the range. Good. Y. Independent is x. So if you were thinking about this, okay, what's going to go on the y-axis from that word problem? Nietzsche? Is the gigabyte based on, so what we're comparing, this flat fee isn't one of the variables, correct? Because that stays constant no matter what you use. So is the number of gigabytes dependent on your cost to subscribe? No. The cost you pay, your bill, is depending on the gigabytes. So the number of gigabytes is your domain or your independent. And then your total cost to subscribe. So I'm going to write it as a subscription cost. That's your y value. So now we're going to write a function rule to represent the total cost per month. Okay? Just a rule for any situation. If the number of gigabytes changes, and then what would be the cost? So what would a function rule be for a flat rate of $15 and then $2 per gigabyte? Okay, we know that to get our total subscription cost, we have, Elijah? We have 2x plus 15. We have that $15 flat fee, and then, yes, 2 times x, which is the number of gigabytes. We already wrote, this is more or less your let statements, okay? We said write a function rule, though, so I'm going to rewrite it as f of x. All right, C, if you use at most 10 gigabytes in data, use the function rule from part B to determine how much the service would cost. How do we set this up, Sean? Correct. So if you at most 10 gigabytes, so going up here, our gigabytes is x. So in function notation, f of 10, or f of x, is equal to 2 times 10 plus 15. So order of op, multiply before you add, and the cost would be $35. Part B, what would be a reasonable domain and range for this scenario here? So if you're going to use, I'm going to draw an axis, if you're going to use at most 10 gigabytes, you could use 10 or less. But you can't go less than what number? 0. So for domain, it would make sense that we're going to have 0 less than x less than 10. So if you didn't use any data, okay, then you would have a bill of how much? 15. So you automatically, for your range, because of that flat fee, you automatically start at $15. So on your graph, that would look like here. For 0, be at 15. And then if you spent the 10, how much did it cost? It's going to stop here at $35 from the problem above. So our range goes from 15 to 35. Part E, if the most that you wanted to spend in any month for an internet service was $50. So you had a budget. You knew that one month you had 50, but maybe you wanted to spend more the next month. So this includes taxes. Use the function rule from part B. So our rule is f of x equals 2x plus 15. If you knew you wanted to spend $50, is the 50 your y or your x? $50. That would be your y value. Okay? So your y, we would replace the f of x with 50 and solve, okay, to determine the number of gigabytes. That was your x. I don't have much room, so let's do this out loud. We have to subtract the 15, and 50 minus 15 is? Then divide by 2. 17.5. Okay. It says, though, how many whole gigabytes? So could you, yeah, because you couldn't do the 18, right? Because you'd be over 50. So the answer is 17. If you had 18, 18 would put you over the 50. Since when you solve, you get 17 and a half. Last part. What would be a reasonable domain and range for this situation? So what's our domain going out to now? 0 to? No, for 17. Because this is the x is your number of gigabytes. Okay? And then your cost is over here. We know we're going to start at 15. And then that's going to go up to when we use 17 gigabytes. That'll be the $50. That's at most we could do. Okay? So our domain is going to be from 0 to 17, and our range is going to be 15. For this scenario, I can spend at most $50. I can spend at most 50, but I have to spend at least 15 because of that flat fee.